Hello everyone, this is Jack Wang from Baicells company. First, thank you for watching this video. Today I'm going to give a brief introduction about the Baicells company and our solutions based on LTE technologies. Hope you can find something interesting and useful in this video. If you are interested in more details, please visit our official websites. There you can leave a message and subscribe your email address there, so you can keep updated with the latest news of our company. Today's introduction including 4 parts. First is a company profile, then is products and solutions about Baicells, then is a case study of what we have done, and finally is some annexes about our products and more information. Generally speaking, Baicells is a company that focused on end-to-end wireless broadband access solutions based on LTE. We are a high-tech company combining the technologies from US and the massive production capability from China. Our main products and solutions cover both indoor and outdoor scenarios, including radio access network, that is LTE small cells, CPE antenna, as well as gateway or SDN or cloud-based EPC network management system, and even CRM. So it means we can provide turnkey solution to operators, including mobile operators and fixed LTE operators, as well as a vertical private network. Our vision is to connect the unconnected and provide LTE service easy as Wi-Fi. I will give some more detailed introduction about Baicells products and solutions. I divided it into several parts. The first is a whole picture about the portfolio, and then it's about the WBB scenario, or you can call it fixed LTE scenario, the mobile broadband scenario, the UE relay cell, the Open RAN architecture scenario, and the end-to-end features. It can be divided into 3 sections. Generally, first is about the core network part, including the EPC, the sound server, the octonode, the OMC and BOS, and the terminal part actually mainly involving the base station, antennas, and the device part mainly related with the indoor CPE and outdoor CPE. This page shows the scenario of WBB solution, or you can say fixed LTE solution, which is used mainly by wireless ISP. So it can be divided into 2 sections for simple. The first is cloud core. It includes the EPC part, including the MME and gateways, and the billing system, the maintenance system, and including the HSS. All these core network elements are software defined and can be deployed on common server or even on cloud. The other section is about the radio access part. Our Unit B is all-in-one box. It's different from the architecture of micro Unit B, which has BBU and cabinet, and you connect the RU or RH with a fiber using C-free interface. We provide everything in just one box. So it means the installation of the Unit B can be much easier. You can find it. And for the CPE part, we have different types of CPE. We have indoor CPE with the Wi-Fi integrated, and we also have outdoor CPE with a normal gain antenna, which is 11 dBi, and also high gain antenna, which is 19.5 dBi, which can greatly increase the coverage. So this can be used in combination to fit for different kind of scenarios for fixed wireless. This picture shows how our software-defined EPC can be deployed. Because our EPC is purely software and can be based on a common IT server, the capex of the whole EPC system can be greatly reduced, can be very capex friendly. And secondly is the flexibility. Our gateways can be deployed in centralized way or distributed ways. For example, here is the capital city. You can deploy the gateway here, and also you can deploy multiple gateways in different cities where the traffic or backhaul can be funded directly to the internet, so you can offload the traffic directly to internet. So the backhaul OPEX or the transmission bandwidth from this kind of cities to the central city can be saved. And the gateway can be even further pushed down to the inode B. We call it a local gateway. So the traffic can be directly offloaded from inode B to internet. So in some cases, this can also improve the flexibility and reduce the OPEX or the backhaul. And the last, with this kind of distributed gateways, the network redundancy is higher, so you will have a more reliable and stable network. And also you can enjoy a lower latency because in some cases, for example, the corporate LTE, the latency is important. With this architecture, we can reach around 30 milliseconds average delay, which is much better than most traditional vendors. Another reason why small cells are more suitable than micro inode B, from the comparison of these two pictures, we can say with the traditional inode B, you need a cabinet to accommodate the BBU, and you need a site room to accommodate the cabinet. But in our case, the integrated inode B has everything, including the radio, the baseband, in one box. So what you need is just two cables. One is for transmission, one is for power supply. So this kind of all-in-one design, compact inode B, can reduce the site requirement and easy. So this kind of all-in-one design and compact inode B can lower the site requirements and make the installation easier. Also, with a smaller footprint, the site acquisition can be also easier. You can install the inode B on rooftop or even on a street lamp pole. And also, without additional cabinet for BBU, the site rental fee can be saved. In one case of our customer, only saving the cabinet can save the rental fee around 300 USD per site per month. So actually, this is a huge save for the overall network. Another innovation we have done is to move the LTE from traditional licensed band to unlicensed band. For example, if we look at the 5.8 GHz, there is a 120 MHz spectrum free of charge. And also in North America, the CBRS band or band 48 has been released for light spectrum sharing. There is around 150 MHz available to be shared. So this is with a huge potential spectrum. With this kind of free spectrum, you can greatly increase or expand the capacity of your system by adding them to the licensed band or just use them independently. So why are we using LTE on this band? Actually, that kind of Wi-Fi based solutions can be also used on this kind of bands. But using LTE is taking advantage of the air interface performance of LTE. Because the RS sensitivity or LTE is much higher than Wi-Fi based solutions, so the LTE can perform much better, especially in line of sight scenarios. For example, if there is some blockings or trees or rocks or buildings, LTE can still keep the connection, but the Wi-Fi based solution will lose the connection. And normally on 5.8, only TDD mode can be supported with the Wi-Fi based solution, but with the LTE we can support both TDD and FDD mode, which means by single hardware FDD you can enjoy much higher throughput, especially for the downlink. You can reach 150 Mbps downlink and 50 Mbps uplink with only one pair of 20 MHz spectrum. Another innovation we have done is moving the LTE from traditional licensed band to the unlicensed spectrum. Why are we doing this? If you look at the spectrum on 5.8 GHz, actually there is almost 120 MHz spectrum totally free of charge. And also in North America there is 150 MHz that can be shared with a very light licensing. So basically they are almost free of charge to be used. Actually, Wi-Fi based solution can also be used on these two bands, but why are we using LTE? Actually, the reason is that LTE has a much higher RX sensitivity compared with the Wi-Fi based solution. The result is that in line of sight scenarios, LTE performs much better. For example, if there is a blocking of trees or rocks or buildings, LTE can keep the connection very good, but Wi-Fi based solution will lose connection. And on 5.8 GHz, normally the band will be used only for in TDD mode, but with LTE, with the Baicells solution, we can support both TDD and FDD mode. In case of FDD, you can enjoy higher throughput, especially in uplink. For example, on 20 MHz, you can reach 50 Mbps uplink and with 150 Mbps downlink. Finally, if we think about the future of the investment, the Wi-Fi based solution actually has no future for evolution, because all Wi-Fi based solution that is used for fixed wireless access or fixed broadband, actually they are proprietary solutions. There is no global standard. But for LTE, actually LTE is the only global standard for the future evolution of telecom. I'm not saying that the future 5G actually is taking more and more higher band spectrum, like the CBRS band actually has been taken as band 42 by ITU, and also the 5G will be considered for technologies like multiplier or LAA technologies. So if you invest with this band, it means you will have a more bright future in the long run. And the next good feature is our layer 2 and layer 3 VPN. Actually, with a traditional LTE solution, you cannot support or enjoy layer 2 VPN, which is very important in some scenarios for the corporate LTE or for the corporate service, because the traditional LTE network or standard LTE solution actually don't support layer 2 VPN. But with our customized VXLAN solution, we can support large quantity of layer 2 with a very simple management and the maintenance of the network. Next one is the layer 2 and the layer 3 VPN we have done based on the standard LTE protocol. Because actually with the traditional or standard LTE protocol, the network cannot support Layer 2 VPN itself, but we are doing some optimization. We use VXLAN solutions to support large quantity of Layer 2 VPNs, so we can perfectly fit the scenario for corporate or enterprise users that need such kind of Layer 2 VPN, because the branches of the company need to communicate or interconnect with each other, so they need to work in the same Layer 2 VLAN. This works as a value-added service for fixed LTE operators. This page is a scenario about a very interesting video surveillance case. Actually, with this special designed eNode B, you don't even need any transmission or backhaul for this eNode B. For example, here is the tower, let's say for some construction field. You can just install the eNode B even with the solar power panel, because the eNode B can be very small power output, so the power consumption can also be very low. So with the unlicensed band, for example 5.8 GHz, you can use it in FDD mode. This kind of cameras, they can integrate the LTE modules and all the traffic uplink, because it's a video streaming through the eNode B, and the eNode B will distribute or deliver all the video streaming with its DL traffic to one CPE. The CPE can be installed in office on the ground. So it means actually for this box, it works just like a Dropbox. You can just attach it to the pole or to the tower. No backhaul, even no power supply cable. So this makes it very flexible to deploy the video surveillance scenario. As we know, actually there are two kinds of main business of fixed wireless access. The first is the home broadband. Second is enterprise broadband. But if we look at the Baicells solution, because we are using distributed gateways to provide a more stable network with a lower latency, that is around 30 milliseconds average latency, and we can support customized Layer 2 VPN. So actually this fixed LTE can be used as a fixed wireless backhaul for the mobile operators to deploy large quantity of small cells. We call it UE relay cell. The benefit is like this. First is the transparent, because the Layer 2 can be supported for the fixed wireless, so the small cells can just connect it via the wireless backhaul, just like via the cable. Secondly is the controllable. Our OMC can provide multiple parameter monitoring, and also with the signal and trace, we can identify any issues or problem of the backhaul. Third is the flexibility. Because the backhaul is based on fixed LTE, so the deployment of the small cells can be almost anywhere. You don't need to lay so many cables for the LTE for the small cells or mobile operator. And also the backhaul can be used not only for 4G LTE small cell, it can also be used for 2G or 3G femtocell. And here is an example of the specification of relay cell and enhanced version. We call it a neutral cell. Later on, I will explain the details. For the relay cell, actually it includes two parts. The first is the backhaul module. Actually, this is a LTE CPE. It can be connected to the fixed LTE eNode B, and this connection over LTE can work as the backhaul for the base station module. The base station can be 2G, 3G, or 4G. For example, if it's 4G, with the Baicells solution, the TX power can be 2 by 21 dBm, and the peak rate for TDD can reach 110 downlink and uplink with 10 Mbps. And for FDD, the downlink can reach 150 and uplink can reach 75 Mbps. And this picture shows the neutral cell inside. Actually, neutral cell is a kind of enhanced relay cell. Why we call it a neutral cell? Because actually this cell itself is consists of 4 blocks. It can include one module, including LTE CPE as the relay over wireless, and integrated with the Wi-Fi module, and the remaining 3 parts or blocks can be used for different bands or even different. For example, this module can be operator A with the GSM small cells. This module can be operator B with another LTE small cell band, and this one can be another LTE small cell for another operator. So basically, this work as a shared infrastructure or shared small telecom tower at a femto level. At the same time, the LTE UE relay or backhaul over LTE, fixed LTE, can also be supported with this kind of architecture. The management or the monitoring of the network is also of vital importance. So we developed end-to-end management of the network elements, including the core part, the radio access part, even include the antenna connection. We can support the real-time alarm for quick response, and we have multiple ways for notification. The RF condition and transmission monitoring can be supported, and once there is some issues or problem, you can use the signal trees for quick troubleshooting. And in case there is some interference happens, our spectrum scanning can raise alert or alarm that trigger the instant attention. I finished the first introduction part, and then here is some cases. Let's see what we have done. First case is what we have done in Pakistan. Actually, this is the first corporate LTE network that has been commercially launched. Azure is the WiMAX operator of Pakistan. It has more than 100 subscribers, and they are migrating the existing WiMAX network to LTE. So they are attracted by Baicells design with a smooth and cost-effective migration from their old WiMAX network, and also our layer 2 VPN for enterprise with a very customized latency. We can reach around 30 milliseconds latency on average. So this can fit for their scenario perfectly. The second case is a satellite backhaul solution. In some remote island scenario, our InnoB is connected to EPC or to internet via satellite backhaul. So basically, our InnoB can support any transmission that is based on IP. This can be quite useful for some scenarios that you need to deploy a InnoB or network in some very remote area. This case is a 9-level site case in rural area. Actually, even although the InnoB is high on the tower, but the CPE actually are blocked by heavy trees. Even in this case, we can reach more than 4 miles with a 60 Mbps per link. for the downlink. So this proves actually LTE can perform much better than Wi-Fi based solution, because in such cases Wi-Fi based solution will lose the connection. And here is another case that shows how small cells can improve the indoor coverage. Actually, with only one small cell, you can cover a whole floor of the office. The downlink can reach up to 90 Mbps. The uplink can reach up to 8.5 Mbps. So in combination with such kind of indoor small cell solution and with a wireless backhaul, you can deploy large quantities of small cells very easily. So this is very meaningful for mobile operators to fill the gap of their network and improve the user QoS and experience. Okay, finally is some brief annexes about the more information. First is a portfolio about the Baicells small cell series. This one is a 2x10 watt InnoB, or you can call it a higher power InnoB. It can cover more than 15 kilometers, even in non-level site scenario. This one is a smaller power. It's a 2x1 watt InnoB, which can also be used for the fixed wireless access. It can reach even 10 kilometers with a high gain CPE. With the normal gain outdoor CPE, it can reach around 6 to 8 kilometers. And this one is the lower power model of the outdoor InnoB. It can provide a smaller coverage for some special scenarios that you don't require too much coverage but higher capacity. And this one is the small cell or indoor small cell that can be used for gap filling or for hotspot traffic offload. Actually, we have shifted quite a lot to mobile operators with this kind of indoor small cell. And also F cell with a lower power, that is a 2x50 milliwatt, which may be only covering your home or a very small coffee shop or restaurant. And here is the innovative products I mentioned before. The neutral cell with it you can support multiple operators, multi-band, and multiple technologies, and even with UE relay embedded. And this is NB-IoT, the Internet of Things InnoB. This is F Cell 2 enhanced version, which can support power line communication for the backhaul, and Sky cells that can be mounted on the drone and provide emergency communication support. And this is Baicells LTE terminal series. This is the indoor CPE with the integrated Wi-Fi, and this is outdoor CPE with 11 dBi antenna, and this is the high gain antenna CPE, which can greatly extend the coverage. Okay, so this is the overall introduction about today's topic. I hope you can find something interesting or useful for you. If you have any comments, you can leave a message behind in the comment area, or you can visit our website for more information, or subscribe your email there to keep in touch. Okay, thank you again.